online class conducted by Jyoti Engineering College. I am Andos Zakrias. I am working as assistant professor in Jyoti Engineering College. Today we are going to solve some of the problems in torsion of thin-walled sections. Last class we derived the equations to find the torsion, shear flow and angle of twist for the thin-walled sections. Here today we solve some of the problems in thin-walled sections. Before solving the problems, we can look at some of the equations used to solve the problems. First equation is torque of the section is given by 2Q into A. A is the area of cross section, Q is the shear flow. Next equation is shear flow Q is given by τ1 into T1. That is also equal to τ2 into T2. This is the second equation. Next equation, angle of twist theta is equal to Q by 2Ag integral ds by T. It is rearranged as 2g theta is equal to 1 by A1 into A1 Q1 minus A1 to Q2. This is equation of 2 theta for cell 1. This equation is generally we use to solve the multiple sections problem. Similarly, for cell 2, 2g theta is equal to 1 by A2 into A2 Q2 minus A1 to Q1. Here, capital letter A represent area of section. Small letter A1 represent ds by T for wall section of cell 1. Small letter A2 represent the integral ds by T of wall cell section of cell 2. A12 represent integral ds by T for the web. It is common for cell 1 and cell 2. Next we can solve some problems in thin-walled sections. First problem 1. A hollow aluminum tube of rectangular cross-section shown in figure below is subjected to torque of 56,500 Newton meter along its longitudinal axis. Determine the shearing stress angle of twist. Assume G is equal to 27.6 into 10 raised to 9 Newton meter square. It is the cross section given in the question. So it is a single cell section with a different thickness throughout the cross section. First we find the torque. First we equate with the torque and find the relation of Q. First torque equation to find torque, mt is equal to 2qa. Torque is given in the question, that is 56,500 and area is found out by 0.5 into 2.5. It is given in the question. So from that equation we can find the shear flow Q. By substituting in the torque equation, we get shear flow Q as 2,26,000 Newton per meter. Next we find shearing stresses throughout the cross section. Shear stress vary according to thickness. So shear stress τ1 along the thickness T1 is found out by τ1 is equal to Q by T1. tau 1 is equal to 80.833 into 10 raised to 6 Newton per meter square. Tau 2 is equal to Q by T2, that is equal to 37.667 into 10 raised to 6 Newton per meter square. Tau 3 is equal to 22.6 into 10 raised to 6 Newton per meter square. Next, we have to find angle of twist per unit length. Theta is equal to Q by 2 GA into integral ds by t. Substituting values in the given equation, Q is equal to 2,26,000, G is equal to 27.6 into 10 raised to 9, A 0.125. Integral ds by t is given as ds is the length of that section by corresponding thickness. So integral ds by t of overall section or cell is given by 0.25 by 0.012, 0.5 by 0.06 into 2, 0.25 by 0.01, and theta is given as 0.0069 radian per meter. Next, problem 2. The figure below shows two-cell tubular section formed by conventional airfoil shape having one interior web. An external torque of 10,000 Newton meter is acting in clockwise direction. Determine internal shear force distribution. The cell areas are follows. A1 is equal to 680 centimeter square. A2 is equal to 2000 centimeter square. It is the figure for given in the question. It is a two-cell section with the two-cell section with the different thickness throughout the cross section, and S is also given in the question. First, for cell 1, we first find out small letter A1. For cell 1, A1 is equal to integral ds by t. That include web also. For it is given as 67 point corresponding thickness 0.06 plus for web ds by t is given as 33 by 0.09. Therefore, small letter A1 is equal to 148.3. Next, for cell 2, A2 is given as 33 by corresponding thickness 0.09 plus 63 by corresponding thickness 0.09, 48 by corresponding thickness 0.09 plus 67 by 0.08. A2 is equal to 2409. Next, for web, A12 is equal to 33 by 0.09, that is equal to 366. Next, we substitute value of A1, A2 in equation for angle of twist. 2g theta is equal to 1 by A1 into A1 Q1 minus A12 Q2. By solving that equation, we get 2g theta is equal to 2.189 Q1 minus 0.54 Q2. Similarly, for cell 2, 2g theta is equal to 1 by A2 into A2 Q2 minus A12 Q1. Substituting the values, we get 2g theta is equal to 1 by 20 Q2 minus 0.18 Q1. By solving 2g theta equation of cell 1 and cell 2, we get that left hand side of both equations are 2g theta. So we can equate equation 2g theta equation for cell 1 and cell 2. By equating 2g theta equation for cell 1 and cell 2, we get 2.18 Q1 minus 0.54 Q2 is equal to 1.20 Q2 minus 0.18 Q1. From that equation, we can get the relation between Q2 and Q1. Q2 is equal to 1.36 Q1. Next, equation for torque. Torque T is equal to 2Q1A1 plus 2Q2A2. Value of torque is given in the question. By substituting the values, we get 10,000 into 100 is equal to 1360 into Q1 plus 4000 into 1.36 Q1. By substituting Q2 is equal to 1.36 Q1, we get value of Q1 as 1.47 Newton and Q2 as 200 Newton. These are some problems in thin-walled sections. Next, we can solve more problems in next section. Thank you for listening to this video. Thank you.